Okay, so this section of the workshop is focusing on the library called Schema. It's a very, very simple library. It is literally one single file. If you go to GitHub for this library, this is the repo, but like this is the code for the library, one single file, total of 770 lines of code. And it's very simple, have an intuitive API, and you can basically add it to an existing project easily. So the introduction to the API, we basically import schema from Schema, and for singular value validation, we just pass it a type. So if we do my schema, create a schema class with an integer type, and when you call validate method on this object using a value, it will either raise an error or it will return the value itself. So quite simple. We can also allow multiple types per value. So let's say we declare a schema using the OR class. So we initialize OR using an integer type or a string type and a custom error message. So it's going to work for string values. It's going to work for integer values as well. And for floating point, for example, it's going to fail with the custom error message. So let's see. We can also apply multiple rules per value. Let's say we want to check for integer, and we also want to check for if the given integer is between given values, right? So we can declare a simple validation check that accepts a value and checks if it's between minimum and maximum. And if not, it returns a schema error. It raises a schema error. It can be any type of error, but this is the standard way of doing things. So declare a schema, try to validate it with a string. It fails the type check. It should be an instance of integer. As an integer, but it is out of bounds. So it is smaller than minimum value. So it's going to fail again, saying that value 9 must be between 10 and 50 inclusive. Again, a floating point value is going to fail due to type check. And finally, if we have an integer between 10 and 50, it returns the value. And again, we can also apply, we can compose these rules, right? In here, we were doing multiple type checks. We were allowing like multiple types. And in here, we are doing like applying multiple rules, and we can compose them. We can do allow integer or float types, but also check if they are between these values. So it's going to work for 10, which is an integer, and it is between 10 and 50. And 10.5, which is a floating point number. And again, it is between 10 and 50, so this should work as well. We can also use schema to validate iterables, lists. So the syntax is a little bit, quite a little bit of difference. So this is the same rule as above, but now we have the rule between list brackets. So the schema declaration, the library parses this declaration, and basically you can use this to validate list of items. So 10, 12, 11, 12, these will all be checked against this rule. For each item, we're gonna check if the item is of float or integer type, and if it is between 10 and 50. And if it passes, then we get the original list. And if it fails, for example, like this is not an integer, this is not numerical, it's gonna fail the type check. This is gonna fail. I can also make it fail the range check as well. But again, we won't be using these libraries most of to validate singular values. We're going to have a payload of some sort, and that is how we use this library most often. So to validate a payload, a dictionary, we basically declare a schema using a dictionary notation. The keys are going to correspond to the keys in the payload, and the values are going to be used for checking the types of the values in the payload. So if you have a schema like first name, last name, birth date, job start date, date types, string types, and this is our payload. We validate it, we get the payload back, right? For example, if you have missing keys, if you are missing last name, for example, schema is going to raise an error. It's going to say your payload is missing last name key. That's the default behavior of schema. Some other validation libraries, they have other types of behavior. Some of them, they just omit missing keys, for example. In schema, if you want to have optional keys, you have to use this optional annotation. So let's say we have a payload with no middle name, and then we have a payload with middle name explicitly set to none. And then we declare our schema like first name must be string, last name must be string, birth date, job date, they should be dates. And the middle name key, the key for middle name, is optional with default value of none. And we are also allowing either string types or none types for this field. So if we validate it using no middle name, this one here, middle name should be automatically set to none. See, it was auto-populated. We should also allow explicit none type as middle name as well. So this also worked out. If I just change this to string, I think this wouldn't have worked. Let's see. Oh. Yeah, it does explicit type check, so it doesn't work. And how about extra keys? So sometimes our payload may have additional keys that we don't know about, and we may want to either allow them or get rid of them. So if we just have extra keys in our payload, other than the keys defined in the schema, we're gonna have an error. So this is our schema declaration: first name, last name, birthday, job start date. And our data, it has a bunch of new keys. If you just try to validate it, it says like the keys are wrong. It's gonna complain, right? So here's a tricky bit. When you declare your schema, instead of using a string key, instead if you use a type for a key, then your schema is going to allow any key of that type. And it's going to use the validation rules corresponding to that type of entry. And this is going to be your fallback. So your explicit key names are going to be used first for matching, and then any additional key is going to be checked against this. So let's try it. So our data has a Boolean extra key and a string as extra key as well. And this thing, it allows both strings and Booleans, so this should just work. And yeah, it worked. And finally, when it comes to extra key handling, if you have this rule, use object as the key and object as the value as well, your schema is going to like just allow everything, right? Any type of key, any type of value will be allowed that do not match the explicit keys. So if you have something like this, it's gonna work as well. And I can add here anything really. it's just going to be super permissive. You shouldn't be doing this anyways, but like this shows you the flexibility of the library.